Shaky license.
How's everybody doing? Fantastic. My name's John, and this is Sub-Zero. We're going to do programming with liquid nitrogen. But before we get started, can you guys tell me if you think I'm dressed this way just to look all sciencey and stuff? Do you think I'm dressed this way for another reason? Yes. What reason do you think that might be? Yes. Safety. Very good. Can somebody tell me one thing I'm wearing that's kind of unusual? Yes, sir. Look. Very good. I have on two different kinds of gloves. On the bottom, I have on a pair of cryo gloves, like this one. Now, they're not called cryo gloves because they make you cry, unless you were wearing this one because it's all cut up. But this one is cut up so you can see what it looks like on the inside. Can everybody see that it has a lot of thin layers of fabric? Did anybody's mom tell them to wear a lot of layers in extreme temperatures? Yeah? Okay, good, good. On top of those, I have on these non-latex nitrile exam gloves. These are basically just to keep the cryo gloves clean because they do cost about $400 a pair and they're not even lambskin or cashmere. What else am I wearing that's unusual? Yes. I have on a long lab coat to protect my skin and my clothes in case I spill things. And I like to spill things, as you can see by my lab coat. What's one more thing I'm wearing that's unusual? Yes, ma'am. I have on safety goggles. Who here likes your vision and wants to keep it for your entire life? I know that I do. It would be a lot more difficult to be a mad scientist if you couldn't see. Not impossible, but a lot more difficult. So I wear safety goggles that protect the front and the side of my eyes. Because I may be a mad scientist, that doesn't mean I'm a dumb one. I also have on long pants and closed-toed shoes. You would not want to do experiments in shorts and flip-flops. I've got my hair pulled back and I've got a microphone on, which is more just to protect my voice. All right, is anybody here dressed like me? No, nobody is. So I should do the experiments. Now, some of the experiments I'm going to do right here in front of you. It's okay, I won't get anything on you. But you need to stay in your seats. And especially, don't touch anything I put on the floor. Is everybody okay with that? It's okay to sit in the aisles as long as you stay behind the front row. We all good? All right, now let's introduce the star of our show. This is liquid nitrogen. Can you see how it's boiling really, really hard? Do you think it's really hot stuff? No, it's actually really cold stuff. Liquid nitrogen boils at 321 degrees below zero on the Fahrenheit scale. That's about 196 degrees below zero on the Celsius scale, if anybody here is from any other country in the world. It is so cold that not only is it colder than anywhere on Earth, it's colder than anywhere on Saturn, okay? And watch if I put it in here. Think tea's ready? It would have to be some really iced tea. If I drop it on the floor, it instantly evaporates and turns to gas. All right, let me get some more. guys think I should drink some of it? Okay, what if I breathe some? Is that okay? Let's see what happens if I breathe some. How do I look? My nose fall off? My eyes come out? My beard fall out? Must be okay to breathe then. Everybody take a deep breath. All right, let it out. What did you just breathe? Air. Very good. What's air mostly made out of? Who says oxygen? Who says air is mostly oxygen? That's a good guess, but it's wrong. Has anybody here ever been around somebody who's been on an oxygen tank? Or has anybody here ever been in outer space? No astronauts? Usually we have one or there we go. I knew we had a couple of astronauts here. Very good. Very good. Well, if either of those things were true, then you know there's one thing you can't have in a mostly oxygen environment. You know what it is? Fire. You can't have fire. If you have fire, you'll have nothing but fire. So liquid nitrogen is actually the major component of air. Air is about 78% nitrogen at sea level. The only thing that makes it so dangerous when it's a liquid is that it's so very, very cold. As a matter of fact, when I was 11, I had warts all over both my hands and arms. I had about 30 warts. It was really disgusting. No girls would talk to me. And I went to the dermatologist. For those of you who are too young to have had any skin problems yet, a dermatologist is a skin doctor. And he came into the exam room with an old-style thermos. I thought, well, it's weird that he would bring a thermos in to examine me. And then he took the top off, and it looked like this. And I said, are you having soup for lunch? And he said no, and he took a long Q-tip, and he stuck it in there, and he swizzled it around, he dabbed it right on one of my warts. And it was the worst pain I had ever felt in my entire life up till then. I was only 11, so I hadn't been in love yet. It hurt so much that I couldn't do them all in one trip. I had to make a second appointment to do the rest of them. But it was so worth it because about 3 days later, they blistered up and I could flick them at my sister. It was very cool. Now we can talk more about things they do with liquid nitrogen or how they make it, but I thought it'd be more fun to put stuff in it. What do you guys say? Okay. We're gonna start with these gloves like I'm wearing. These are nitrile gloves. I don't want you to think I'm cheating you, so would you tell me if that is a stretchy glove? Pull on it good. Is that a stretchy glove? Very good. How about this one? Is that a stretchy glove? Yeah, that's pretty stretchy. And is this one a stretchy glove? It's not stretchy. Is that stretchy? Yeah, that's stretchy. Okay, good, good. How about this one? Is it a stretchy glove? No, it's not stretchy. It's stretchy, isn't it? Okay. Now let's put our stretchy gloves in the liquid nitrogen. We're leaving them in there for 10 seconds. You ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Here we go. Not very stretchy anymore, are they? It's a good thing I didn't drink any of this, isn't it? Even the gloves in my hand are coming apart. You can see that it turns this latex-like material called nitrile into like a dry leaf in just a few seconds. Now let's try some more things. First, I want to put these bouncy balls in there, and let's verify these are real bouncy balls. We'll go ahead and bounce them. That's pretty bouncy. Let's bounce it right in there. And the other one, pretty bouncy, good. And let's also, while those are sitting in there, let's put some pennies in there. Now I've got a couple of pennies here. Everybody knows a penny is a penny, they're all the same, right? Well, actually that's not right. You see, pennies are made out of different metals, or mixtures of metals called alloys, depending upon when they were minted. Back during World War II, they made pennies for a while out of steel. More recently, with all the copper used in computers and electronic devices, it got to the point where making a penny out of copper costs more than a penny. So, today pennies are made out of mostly zinc. Now in this cup I have some old pennies from when I was a kid, and one new penny is made out of mostly zinc. I'm going to put them in the nitrogen and see what happens to them. And we'll let all that sit for a minute, but while that's sitting, let's check on one of our balls. Oops, let me get this. Let's see how that one bouncy ball is doing. It's only been in there for a little while, but it's already lost its bounce. So we're going to leave this here. We're going to let everything sit here for just a minute. While that's sitting, I was wondering if you guys could help me out with a problem I have. You see, today is the first day of Mummies. I don't know if many of you have seen it, but it's very exciting. And after work today, I was going to throw a party, and everybody knows what you need for a good party, right? Balloons, right. So I was going to bring all these balloons home to my party. But then I remembered that I rode the Gold Rush bus to work today. And there's no way they're going to let me take all these balloons on the Gold Rush. So I thought, well, how am I going to get these balloons home? And I thought, I know, I'll put them in my knapsack. My knapsack's about this big. Can I fit all these balloons in there? I'm going to try. Let me start out with this white one. That one goes in, and an orange one. Okay, I got two in there. I need a pink one if I want girls to come to my party. You have to have pink balloons if you want girls to come to your party, right? That's three. I'll put a yellow one and a red one. That's five. I'll put two blue ones. That's seven. And a light blue one, 8. It'll go in there. Should I stop? It's getting pretty hard. Should I put this one in too? Okay. And the black one is 9. Okay. So I know I can get all my balloons home. All I have to do is figure out how to get liquid nitrogen in my knapsack, right? But here's the question. Are these balloons going to be any good when I get them home? No. Now, did I just ruin 9 perfectly good balloons? Okay. Well, we'll take a look at it. Before we do, I want to remind you guys what we talked about at the beginning of the program. It's okay to be on the floor. If you guys can scoot back, though, you need to be behind the front row. You need to scoot back a little bit, too. Scoot back, okay? And we need to remember not to, you can sit down, it's okay, not to touch anything I put on the floor. Can we all remember that? Okay. I think you guys are right. You can see these balloons are no good. You can see they're completely deflated. They're no good at all, right? Those balloons are worthless, right? I should have waited till I got home to inflate them, right? Those balloons are no good, aren't they? They're no good at all, right? What are you talking about? I saw them. They're no good. They're no good at all. Whoa! What's going on here, guys? Are they alive? Are they alive? Is it magic? Could it be science? You think it's science? Okay, who knows? Who thinks they know what's going on here? Who can tell me? Yes, sir. What's going on? What's going on, sweetie? Okay. Who's it? Yes, sweetie, what's going on? They can't be deflated. Okay, because they're tied up. Okay, good. Anybody else? Yes. The air gets colder. Air gets colder and it condenses. Very good. Go ahead, sweetie. One more time. You're not sure? That's okay. All right. Now, let's think about some things here. First, let's review some things we've already talked about. What's in a balloon? And what is air mostly made out of? What do we say? Nitrogen. And what's in here? So the same thing that's in here is most of what's in the balloon. Now, let's think about this. Suppose you're waiting for the school bus, all right? And it's a really, really cold day, and the school bus is 20 minutes late. So when you get on the bus, you're really cold. and all your friends are on the bus. When you're really cold like that, do you want to sit close to your friends and snuggle up, or do you want to sit far away? You want to sit close. You want to snuggle when you're cold, right? Now let's suppose it's a really hot day, and you go out on the activity bus with all your friends in the middle of the summer, and all day you play kickball and dodgeball and basketball and volleyball, all day. And you get back on the activity bus at the hottest part of the day, and it's not even air conditioned. And all your friends are on there too, but they're all kind of sticky and smelly and sweaty and funky. Do you want to sit close to your sticky, smelly, sweaty, funky friends when you're really hot? I mean, you're my friends and all, but come on, right? Well, so let me get this straight. When you're cold, you like to be close together. When you're hot, you like to spread out far apart. Is that right? Chemical elements are just like you. The air didn't go anywhere from these balloons. It's still in here. It just condensed, like my friend here. It scrunched up and became a liquid. It turned into a little pool of liquid. And liquids take up much less space than gases do. But let's try this.